Good evening, dear friends. Now I shall discuss the related fundamental formula with Ohe designing, but it will be in various steps because it's a long chapter, so it will take time. Step by step, I'll proceed. Designing of Ohe on curvature track is really difficult. Like rope, contact and catenary wire laying on curvature, if the distance of two consecutive masts are more, the wire will be out of pantograph running zone, as the wires between the two masts will remain straight, but the track is curvature and away from the center, causing out of pantograph zone. Means in a circle, if you erect one mast in one end of an arc, then other mast at the end of the other side of the arc is curvature, but the contact wire that we will connect with the mast will be in straight. So the track center will go out of this contact wire. So for this we have to reduce the distance between the mast, small span, it is called span. Distance between the two masts is called span. We have to reduce the span so that slowly contact wire diversion will take place and it will remain on pento running zone. But if the distance is more between the two masts, the pento will go out of the contact wire and pento will break. So step by step I will discuss the formula related with it and how to design it, the Ohe. Let's see. So it has been seen that the green portion, that is pento running safe zone, and the contact wire, it is not in the same line. So the pento will go outside the contact wire and pento will break. So we have to design the distance between two masts. What is the limitation? What is the formula? I will discuss it step by step, but with various videos. Thank you. Let's see how far we can discuss today, because it is 8:30 evening. I have some little time in hand. Let's see. From the figure below, you can see that if the span is more, then contact wire will be out of the safe zone of pento running line that is shown in green. But if you make the span smaller, then it can be easily taken. So more curved span is less. Our Ohe span is restricted to 72 meter maximum. Nowadays it is 63 or 67.9. 5, sorry. The multiple of 4.5 and the minimum span is 27. the multiple of all span must be 4.5. Less than this 27 meter can be used in the siding what that cannot be avoided, and it can be reduced to 18 meter also, 18, 20, 2.5, then 27. But it is exceptional case, mainly in the unimportant line, siding or slow speed train where running, there you can utilize it. Now, every curvature is a part of a circle. Our curve is maximum 9 to 10 degree. So, if you draw a circle, then the radius of that circle that indicates the curvature is called radius of curvature. Now I will discuss it with drawing. What is radius of curvature, what is degree of curvature, and what is the span due to this degree of curvature, that all can be calculated. Here the mast is shown in black color. Initially the two masts at the two end of the curvature, the pento shape zone is out, so you reduce the span. That means the black spot is close to each other. It will permit the running of the pantograph. Okay. Dear friends, any curve or arc is a part of a circle. In railway track, the curvature varies up to 9 degree, 8 degree, 10 degree maximum. So as the degree is little, the track in the curvature can be taken as almost straight for 100 feet. The surveyor use 100-foot chain, so our system will also use 100-foot chain. If you measure the distance 100 foot of the track, then assuming a triangle in between the straight line to the center O, the distance OC and OA, also the OB, is the radius of curvature. It is the imaginary line, that O, because the length is inside the earth and the length is too much. Now we draw two triangles. AOC is the main triangle, and then the angle between AOC is called theta, and from the midpoint of AOC or ADC, D point is the midpoint of AC, and from there we draw a line up to O. So the new angle is theta by 2. Both sides is theta by 2 of this division. Now with the 100-foot chain we measured the track length, and as the theta is small, ABC is equal to ADC can be told. That means ADC also 100 feet. Now if you think the triangle DOC, then the sin theta by 2 is equal to OC by OD. Sorry. DC by OC. DC by OC. Or DC is equal to half of AC. That means 100 divided by 2 is equal to 50. 50 and OC is equal to our radius of curvature. Now when theta is becoming small, sin theta is also theta. For example, sin 0 is equal to 0. So when the theta is very small, sin theta is equal to theta. Here now sin theta by 2 is equal to theta by 2, as the theta is very small. Then you convert it in the radian. So the value is coming, radius of curvature is equal to 5728 by theta foot, or 1746 by theta meter. So radius of curvature you can easily find out by putting, for 1 degree curve it is theta is equal to 1, for 2 degree curve theta is equal to 2, and you can easily find out the radius of curvature. If you get the radius of curvature, then some other formulas will come from where you can suggest the span. You need versine, you need the span length calculation. So that will I'll discuss later. Today is up to this.